Hello everyone, my name is Daniel Mason, and today I'm going to be showing you how to do the Do 1 assignment for the Comparative Effectiveness lecture. So this assignment, the Do 1 assignment for this lecture is actually a two-part assignment. The overall goal is for us to complete a comparative effectiveness study, and for the first part we're going to be identifying which two patients in the following table, which I'm going to show later on, could serve as match controls for their cases. So we also have to select the possible controls randomly using the lowest random number provided. And then for the final part of this, we're going to show a Kaplan-Meier survival plot of patients with no falls. So the next part of this assignment is going to be dealing with two doctors, Dr. Jones and Dr. Smith, and looking at their practice pattern. And once we do that, we're going to have to answer the following questions. What is the expected length of stay for each of the clinicians? What is the expected length of stay for Dr. Smith if he were to take care of the patients of Dr. Jones? And what is the expected length of stay for Dr. Jones if he were to take care of patients of Dr. Smith? So going back all over to the first part, here's the data that is given to us. We see the two highlighted patient IDs, which is going to be patient ID 1 and patient ID number 3. As you can see, these two cases, there are two cases where patients receive intervention, which is what I just mentioned, patient 1 and 3, and the other 7 cases is where they did not receive any intervention. So the first step for the assignment is going to be to find the standard deviation. So to find this, there's a number of different ways we could do it, but the way I did it was to go on Excel and plug in the formula. So what we're going to do is select all the ages in the table once you've copied it over to Excel. And then after you do that, you click one of the cells at the bottom, hit the equal sign, and then you're going to type stdev.s, and then hit the parentheses, and then you're going to type the cell numbers. You're going to type the cells where the first age and the last age meet, or where they start and end. And then once you hit the equal sign, it's going to give you the standard deviation, which is going to be 8.89. Now that we have the standard deviation, we're going to use that number to find the lowest random number. So from using the standard deviation, in case 1, we found out that patient IDs 2, 8, and 9 are the ones that fall within the standard deviation. We know this by looking at case 1. We take the age from it, which is 65 years, and then we add and subtract 8.89, which is going to give us two different numbers. These numbers are going to be 56.11 years and 73.89 years. For case 2, we found out that patient IDs 4, 5, 6, and 7 are the ones that fall within the standard deviation. We know this by taking the age from the second case, which is 84 years, and doing the same thing. We add 8.89, which is going to give us 75.11 years and 92.89 years. So now we know the lowest random number from case 1 is going to be from patient ID 8 and 9, and from case 2 it's going to be patient ID 4 and 6. We know this by looking at the chart on the right, and we look at the random number section. I highlighted case 1 blue, and I highlighted case 2 red. So if we look at case 1, the lowest number you can see is going to be 0.16 and 0.17, which comes from patient ID 8 and 9. And from case 2, it's going to be 0.7 and 0.72, which comes from patient ID 4 and 6. Now we're moving on to the Kaplan-Meier plot of the Do 1 assignment. And for this one, we're going to be looking at the cases. So this is the data that we were given. So with this data, we calculated the number of patients at risk of falling and the number of patients who don't fall. So looking at the data, we know that patient 1 and patient 3 are at risk, and this is going to be 2 patients. Now same thing, except we're going to be looking at the control instead of the cases. So this is also the data we were given, which is actually, the numbers are different from the previous data. And just like the last one, we're going to calculate the number of patients at risk of falling and the number of patients who don't fall. Looking at the table above, we know that the number of people at risk of falling is going to be 4. So after we complete that, we're going to have to make this Kaplan-Meier plot official. So we're going to be doing this in Excel. So what you need to do is copy the data from the last plot, from the last two data onto Excel, and then we're going to highlight all of the data. Once you highlight it, you're going to go to the Insert tab and then click Insert Line or Area Graph. Once you do that, this graph is going to be one of the options that pop up, and you're going to click it. So this Kaplan-Meier plot above shows us the cases and controls over a 4-month period. So now that we finished the first part of the Do One assignment, we're going to be moving on to the second part of the assignment, which is going to be looking at Dr. Jones and Dr. Smith's practice pattern. So as I mentioned earlier, we're going to be answering these 3 questions. What is the expected length of stay for each of the clinicians? What is the expected length of stay for Dr. Smith if he were to take care of patients of Dr. Jones? And what is the expected length of stay for Dr. Jones if he were to take care of patients of Dr. Smith? So these are the patterns that were given to us that we're going to have to use to answer the questions. There's a lot of numbers on it, and there's going to be a lot of calculations that we have to do. So the first question asks us to find the expected length of stay for Dr. Smith. To do this, we're going to need the data from the previous slide. From there, we're going to have to do some math to get the probability of branch numbers. Once we have that, we'll multiply it with the length of stay. That's going to give us the expected length of stay for each patient. And then what we have to do is add those. We get the length of stay for each patient, then we add the numbers up, and we'll get the expected length of stay for Dr. Smith. Here we're going to be doing the same thing we did in the previous slide. We're going to do some math to get the probability of branch. We're going to multiply that with the length of stay, and then we're going to get the length of each person. And then we're going to add it all up, and we're going to get the expected length of stay for Dr. Jones. The next question asks us to find the estimated length of stay for Dr. Smith if he took care of Dr. Jones's patients. Just like the last 2 slides, there's going to be lots of math involved with this one. So we're going to be using the numbers from the patterns to find the probability from Dr. Jones. And then we're going to multiply that by the length of stay. And then that number we get, we're going to be doing that with each of the patients. And then the final number, we're going to add them all up, and then from that we get the expected length of stay for Dr. Jones, or for Dr. Smith if he took care of Dr. Jones's patients. So this final slide is just like the last 3. Again, lots of math involved. We have to look at the patterns to find the probability, and then once we get the probability, we multiply that by the length of stay, and then we're going to get a number from that. We do that for each of the patients. We add it all up, and then we'll get the expected length of stay for Dr. Jones. Thank you everyone for listening. That's going to be my Teach 1 assignment.